Hi there. So today I wanted to go through how to recreate this that you see on screen. It's a field of 2D game objects that are moving in random directions and at random speeds. And I thought it makes a cool effect, so we'll be going through that today. Now if you'd like to jump straight to the code, that's in the description as always. And if that helps you out, please hit the like button on the video. That really helps me out. So without further delay, let's jump straight into it, and we'll be starting with a fresh new scene as always, doing it from scratch. Okay, so we have a fresh scene here. I'm going to do a bit of scene setup very quickly before we jump into the code, but it won't take that long. So I'm going to add a 2D plane here that I'm going to put my background texture on here. Now you don't need to do this step, but I thought it would be nice to have something in the background to look at. And I know it's a 2D effect, but I do prefer working in 3D because it's a 3D game engine after all. And games in 2D do rotate on the third axis, the Z anyway, so. Okay, so this image here is 720p. I'm going to scale it up a little bit to match that. 7.2. Let's zero out the position. And we'll set the rotation to standard up. Now I don't like working with objects or games at the origin because I don't really want the minus numbers so much, so I'm going to offset this a little bit. Just kind of push it up out of the way from the origin. Keep our numbers in positive. And then I can remove this collider, we don't need that. And I'll call this background. And I'll also push it back on the Z to 2. So we'll have our ships moving with a Z depth of 1, and then the background will be behind that, so that will be 2. So now the background's set up, let's move the camera to look in the right view. So we can move the camera the same as the background plane, so they match. And also, we don't need to have the far clipping plane that far behind, so we'll change that to something like 20. Great. And then we'll just change the size a bit so it encompasses the whole background. Perfect. Now you can see it's reflecting a bit, and when we go to the game view it's quite dark. So let's quickly create a light for that. Directional light, nothing fancy, just have a light at the origin. And it will point in the Z axis, that's fine, it's great. So now we have a light, it's got a bit of reflection there that we don't want. So we'll just go to our background, we'll go to our texture, and we'll turn off all highlights and reflections, don't need any of them. Not for this. Perfect, so there we go, we have a nice background. Okay, the next object we're going to need is an object to tell us where the game area is, where our ships are going to be. So I'm going to make an empty one and call it game area. Now this is just to tell the scripts where to be, and I will move this the same, 150. And this time I'll put it on the depth of 1, so this is depth of 2. This means this background image is behind our ships. And then a depth of 1 is where all our ships will be. And then the last object we need here is something to spawn our ships. So ship spawner, there we go. Okay, so now we're going to need a prefab for our ships. So let's create an empty game object here. We'll call it prefab ship. And this will be the master, the parent of the top of our prefab. So we make sure it's nice to have everything here zeroed out on the top of the prefab, and then we'll take our sprite and we'll put that underneath, and I'll call this sprite. So this is kind of like the motor, the driver, and then underneath this is the image. And then just to turn that into a prefab, we can drop that there and then delete the one in the scene. There we go, we have our prefab. Now I can go inside that, make sure this is zeroed out and everything. So now we'll go to our sprite, and if you have anything you want to do to manipulate this, you can do it here, just so we keep the top level clean. So here I might say, I'm going to do a bit of scaling, maybe change some of these, that's fine, keep that like that, and that's all zeroed out and clean. Go back. And then lastly, we're going to want to create our scripts. So there's going to be 2 scripts in this. The first one will be a script for the spawner. And what that's going to do is it's going to come along and say, okay, create these ships and tell each ship which direction to go in, where to start from, what speed to go at. And then there's going to be a smaller script attached to the ship prefab, which is just going to be like a motor or a driver. It's going to keep the ship going until it gets to a certain threshold, and then it's going to destroy itself. So let's create those two empty scripts now. The first one will be script, and we'll say ship. And the second one will be ship spawner. Nice. So let's attach those scripts. So the spawner one will be on the spawner. And then we'll just select the prefab and we'll attach the script one to that one. There we go. So it looks like everything in the scene is set up and we can now jump into these scripts. So let's start off with the spawner. Okay, so now we have our spawner script open. The first thing we're going to do here is just create all our variables here, and then as we're creating them, we can run through what they're going to be for. So the first thing we're going to want, game object, and it's going to be game area. This is so this script can access the position data of the game area to know where to put the ships when it spawns them. And then we're going to have another game object called ship prefab. So we have the template that we're going to spawn new ships from. Okay, so now some ship information. We're going to have a ship count. It's going to start at 0. This tells our system how many ships we have active. Then we'll have another int, which will be ship limit, and it will say how many ships can exist on screen at any one time. So we'll probably set this to about 100, or maybe 200. Okay, and then the last int here will be ships per frame. Then we'll say 1 for default. So what that'll be is every time this script runs, how many ships is it going to be creating? Now by default it's going to be 1 because I don't think you'd need any more than 1, but it gives you flexibility to have that number there. Okay, moving on to spawning. So we'll say public float spawn circle radius, and then this is 150. So to get the random positions of the ships that are spawning outside the game area and coming inside, we'll be using a circle. Now there's something nice Unity provides, which is called inside unit circle, and it allows you to create a random position anywhere inside a circle. So what we're going to be doing here is we're going to be setting that circle to bigger than our game area. So then all the ships will spawn outside the game area and then travel into view and then outside of view again. And then once they leave the view area, we're going to have a def circle radius, which will be where the ships, when the ships get too far away from the game area, they will destroy themselves. So we'll go def spawn circle, and we'll set this as slightly bigger. So they'll spawn at a radius of 150. They'll travel inside the game area in view at their random position and direction and speed. And then they'll leave the game area, and once their radius hits 160 on the other side, it will destroy itself. And then finally, the last two variables here, we're going to have another public float, and this will be our speed range. So we're going to say fastest speed is about 20, and then our slowest speed will be, let's say 1, and then slowest. Okay, and I'll leave them all as public just so we can access them later through the ship spawner inspector here. But let's go ahead and go back to the scene anyway and connect up these two here. Just wait for that to compile. Ship spawner. Okay, so we will put our game area here and our ship prefab template here. Cool, so we've got a nice set of defaults. Let's go back to our script. Okay, so the first function we're going to go through is the random position function. And this one will be creating a random position along a circle just outside the game area, so the ships can spawn on the outer edge and then travel into the game area and then travel back out. So let's create the function for that, and it will return the position as a vector3. We'll say get random position, and then vector3 position equals random dot inside unit circle. Okay, so inside unit circle here will return a random position in 3D in a circle with a radius of 1. However, we don't want our ships to spawn inside the circle on the screen. We want them to spawn outside and travel inwards. So we can say on the end of that, dot normalized, And then what that'll do is that will normalize the random position that we get and essentially pushes it to the outer edge of the circle. Now if I show you this image here on the left of a circle, if we just use random.InsideUnitCircle, we will get loads of different positions inside this circle. However, when we use .normalized, it pushes all those random values or random positions that it generates to the outer edge of the circle. It's as if they've been normalized. So this is very helpful for us because it will create all these random positions on the edge of the circle that we can use. Okay, so now we have our random position here. Don't forget InsideUnitCircle generates that random with a radius of 1. However, here we have a spawn circle radius which is much bigger than 1. So we can say position times equals and then spawn circle radius. So what that'll do is it will magnify our random position that's been created inside a tiny circle, and it will push that up so it's now equivalent of being generated on a much bigger circle. So we're kind of taking this unit circle with a radius of 1 and we're magnifying it by a value that we're specifying up here. So we can now randomly generate positions on a much bigger circle. Cool, so we have our random position. Now we just need to offset it to make sure that it matches our game area. So we can say position plus equals game area dot transform dot position, and that will take our random position that's been generated at the origin and we can offset it sideways and up. So now the center of our circle that we're spawning ships on will be at the center of the game area, so they'll match each other. And then after that we can return position. Cool, so that's the start of our random position function. So let's put somewhere where we're going to use it. So in the update, as you can see here, we have an active ship count but a ship limit. So every time this script runs, what we want it to do is to check how many ships we have and whether we have hit the limit or not. If we have hit the limit, don't make any more ships. However, if the count is lower than the limit, then top the number of ships back up. So on update, we'll have a function that we'll call maintain population. And we're saying here, every time the script runs, we want it to maintain that upper limit of 200 ships. So we'll create that function here. And then here we'll say, okay, so if the ship count is less than the ship limit, so if there's still a few spaces for ships to be generated, we'll want to generate some more ships here. Now this is where the ships per frame comes into play, so we'll create a for loop here. We'll say for I equals 0, if I is less than ships per frame, I plus plus. So you don't need this for loop here. You can have it where every time this update function runs, it creates one ship, runs one ship. But if you're finding that ships are dying faster than you can replace them, then maybe you can update this ships per frame value here so that you create, if I change that to 10, then the script will run and it can create up to 10 ships per frame. So if you find that you have a lot of ships or game objects dying very quickly, then increase this number. So I'll leave that here for flexibility, but you don't necessarily need it. Okay, so now let's use our random position function here. So we'll say vector3 position equals get random position. Okay, so now we have a random position for the ships to start at. We're going to want to create a new function here called add ship, and it will take as an argument the position, but it's going to return, I'll say this. So what it will do is this add ship function will create a new ship, set it up, and then it will return it for use later on in the script. Now I'm returning the script instead of the game object because I find you have much better access to the game object when you have the script rather than the game object itself. Because if you have the game object and you want the script, you have to say GameObject.getComponent. But if you have the script, you have access to the transform and the game object just with a simple .gameObject or .transform. So I find passing around the scripts is so much better than passing around the game objects. That's just personal preference. Okay, so the first thing we want to do in this add ship function is we'll say ship count plus equals 1. So here we're kind of reserving the slot for the ship before it's been created, so we don't over create too many ships. So I'll change that value first. And then this is where the instantiation comes in. So we'll say game object new ship equals instantiate. And the first argument here will be the ship prefab, the template to use. Then we'll say put it in this position. And now we need the rotation. Now there are many ways to do this. For example, we could use raycasting to point the ship towards the game area and kind of get a random direction that way. But I didn't want to use that because I don't think you need to use Unity physics for this. You can just do plain numbers and vector math and it'll be fine. Another way was to use colliders, where you have colliders outside the game area and they will detect when ships are born and die. But again, I didn't want to use colliders. And then another way is purely just use random and keep generating random numbers, random directions, until one of them points inside your game area to have a good path through the game. So I thought that's inefficient as well. So for this, what we'll do is all the ships that spawn around the outside, we will point them at the center of the game area, so they'll all be facing inwards, and then we'll rotate them a bit left or right by a random value. And it turns out doing it this way still creates a really nice effect, so we're going to go with that. Now instantiate here only accepts quaternions as the argument, not the vector3. So we'll say quaternion dot from to rotation. I did also try look rotation, but I prefer this one. So this takes two arguments. The first one will be where do you want to rotate from and where do you want to rotate to. So in this 2D game, up is Y, and every ship that's going to spawn by default is going to be pointing up. So we will say vector3 dot up, and we want you to rotate from looking up to looking towards the center of the game. And the easiest way to create a direction vector is just to say target position minus the object position. So the target position is the game area dot transform dot position, and then we'll say minus the position that we're given the ship here. So that will say rotate from looking up to looking at the center of the game area. And then the last argument is a parent, so I'll just say game object lowercase g, so I reference the game object that this script is attached to, dot transform. So create this new ship using this template at this position, using this rotation, and parent it under this game object. Now why is that still, oh yeah, I forgot a bracket there. Good. So this add ship function will create the ship and then just set some basic attributes. So let's grab the ship script from that ship. So we'll say we've got a new variable here, ship script of type ship. Then we'll say new ship, which is our new game object, dot get component of type the ship script. Okay. And we haven't set up the ship script yet, but let's finish this bit first. So we'll say ship script dot ship spawner equals this. So we want our ship script to be able to access this script you see on screen here. So I can say equals this, which will reference this instance, which is great. And then we'll say ship script dot game area equals the game area. So the ship has access to the game area as well. And then lastly, we will say ship scripts dot speed. And then we're going to give this a random speed between the values above. So we'll say random dot range. And then we want slowest and fastest. So I'm saying here the speed for this ship will be a random value between our values here, the slowest and the fastest. And then to close this off, we'll say return ship script. So we have access to this new ship further in the code. Okay, so I'm happy with that function. So let's go ahead and use it. So we'll go back up to our maintain population function here, and we'll see each time it goes through, it gets a random position for this ship. Now we want to add that ship. So we'll say ship script would be new ship equals add ship, and we want to pass through position. Now this will return, we have our new ship here ready. And then just before we go any further with this script, let's try and run this to see how far we get. So before we can run this, we just need to set up our ship script here really quickly. Now it's quite a small scripting compared to this one, but we'll set it up now anyway. So let's... Oh, and when I went to open that up, I got an error. Line 35. So looking back at the ship, line 35. Yeah, you can see I've put commas here instead of semicolons. Save that again, go back to our scene. And that's just complaining to say that our ship script hasn't been set up yet. So we'll go ahead and open that up. Okay, so we won't need to start for this one. Go ahead. So this one just has 3 variables. So the first one, public ship spawner, which will be our ship spawner. Now it's going to need access to this, so when the ship gets too far away from the game, so it needs to be able to tell the spawner, I'm destroying myself, so reduce the amount of ships that you're tracking by -1. Next we'll have public game object, and that will be game area, just so this ship knows where the game area is. And then the third one, which is the last one, the speed of this ship. Okay, so we have 2 functions we're going to need to make here. The first one will be our move function. Now I always try to keep my update as clean as possible, so just move this functionality from the update to move. And then let's go ahead and give this some code so it will be constantly moving. So we'll say on this one, transform.position. So the position of this ship plus equals transform.up times time.delta time times speed. Close that off. So to break this line down, we'll look at this bit first. So when we created the prefab, our sprite of the ship was looking up in the y-axis. So up is forward for the ship. So by saying position plus equals transform.up, we're saying every time this runs, I want you to jump forward a little bit in the forward direction. Now we then times this by a speed value to magnify how far to jump per frame. But then before I magnify my transform.up by a speed value, I'm going to say speed times delta time first, which means it'll make the movement a bit smoother. And then if you do have a lag spike for whatever reason whatsoever, this will still maintain constant movement. Whereas if I didn't have this section, and I just said transform.up times speed, and there was a lag spike, your ship would go from its current position and then zoom miles away. So it wouldn't be smooth. So this protects you from that. Okay, so this one line here will keep our ships moving forward in whatever direction that transform up is currently moving. Now you see how I've done transform.up rather than vector3.up? Well, vector3.up is world space up, and transform.up is the local up for this ship. Or in our case, because it's a 2D game, it's the local forward. So we have another line here to add, which will be float distance equals vector3.distance. And here we're going to monitor the distance between this ship and the game area. And we're going to say, if you get too far away from the game area, you are to destroy yourself. So we'll add here, get me the distance between the position of the current ship and the center of the game area that you are going through, dot position. And then we can say here, if the distance between you and the game area is bigger than the ship spawner dot death circle radius, then I will want you, we'll have another function here that will say remove ship. So if we go back to our other script quickly, you can see here that we have a spawn radius and a death radius. Now they'll all spawn at 150 away from the center of the game area. They will travel through the game area, out the other side, and then when they get to the other side, when the radius becomes 160 or bigger, then they've left the game completely and we want to destroy them. So when we go back here, we're saying that if the distance between you and the center of the game is further away than the depth radius, then it's time to remove yourself. And then we can add this function here, and we can say void remove ship, and we can use the keyword destroy every time. Game object, nope, lowercase g. And now the ship's been destroyed. We want to update the ship spawner to say that we have destroyed one ship. So we'll say minus equals 1. Now we put destroy first, so we make sure that the ship is destroyed and removed from the game before we're then telling the ship spawner that there's a spare space to make another game object. Now that is it for the ship script. It's pretty much all it needs to do is just keep the ship moving forward until it gets too far away, and then it destroys itself. So if we go back to Unity, let's see if there's any errors now. Nope, good, nice and clean. Okay, so we'll go back to our ship spawner, back to where we were. We were here. We get a random position, and then we create a new ship at that random position. So, oh yeah, we were going to try and run this now, weren't we? So, save this, go back to our game, we'll click play. We'll go to our scene view. You can see here, okay, we have all our ships coming in. Now that's what we wanted. However, the ships seem to be a bit small at the moment. And the radius, the spawn radius of the ship seems to be way bigger than it needs to be. So this is where we can go into our ship spawner here and we can play with these values. Now I already tested this off screen to get the perfect values, just so I didn't waste your time. But so a good spawn radius for this is 80. And then the depth radius needs to be just slightly bigger. Otherwise ships would end up destroying themselves before they even begin their journey. And then I want a nicer speed variation, so I'll say between 0.75 and 12. And give me 150. We can move our ship spawner to 000. Make that nice and clean. Click play again. To our scene view. Okay, so now they're spawning much closer to the circle, that's good. But we still need to fix the scale of these ships. So let's quickly check if the ships, there you go, so the scale isn't being affected here. So we know that the scales are not being manipulated anywhere. So we'll go back inside the prefab. Look at the motor, no, all the scales are good there. So we'll go to the sprite. So it looks like these values here aren't big enough. So I'll say something like 4 and 2. Okay, let's go back to our scene and play that again. Perfect, much better. So you can see how now they all go to the center and then they all start flying away. So if you go to our scene view, you can see them here. But if I just restart that, now you can see here the spawn limit is 150. Now if you want to see the circle that it's going to be spawning at, a good way is to play the game, then pause it straight away and go to scene view, and you can see here, this is the circle it's going to be spawning on. This is what happens when you do random.InsideUnitCircle.normalize. It will give you loads of nice positions on a circle. Now if you want a better view of that, you can crank up your ship limit to say 1000, then unpause and pause again, and you can see you get this nice circle. So let me just unpause that again. So you get this nice constant spawning of ships, very nice. Now I know there are going to be ships that are spawning outside here and outside here, and I know that's a bit annoying, but unfortunately an inside unit square function doesn't exist. And the alternative to try and generate random positions along a square outside here is just a bit cumbersome, and this works really well, so I would recommend sticking with this. And also let me show you here. So if we go back to the script, so here where it's normalized, now if I remove that and I just have inside unit circle and I'll save, so now when I hit play it will show you exactly the kind of vectors that this bit here returns. So let's go back, click play, and then pause straight away, you can see now we have random values everywhere, not just on the edge of the circle, but inside the circle. So we'll go back and play, and they're nice and everywhere. But we don't want that. We want them to spawn outside and then enter. We don't want ships to be popping up on screen. That'll break the immersion a little bit. So if I go back to the script quickly and just undo that, and then I'll hit play again, just because there's something I wanted to show you. Now, so all of these ships are now facing the center. So when they are moving forward on their transformed up, they are moving towards the center. And then you'll see when they get to outside further than the spawn circle, they destroy themselves. And when they do that, we get new ships spawning and coming in. So that's the beginning of the nice effect. And now they all have their random speeds and they all have their random starting positions. We want to give them a random variation to their directions, so it doesn't look so artificial the way they all move to the center. Okay, so let's jump back to the script. So luckily this is actually a really easy thing to fix, adding the random variation to the direction. So we'll say here, actually this should be ship script. Okay, so we'll say ship script dot transform dot rotate. So remember, all our ships point directly to the middle of the game area, but we want to offset that a bit. So we're going to rotate on the z-axis, which in Unity is vector 3.forward. We're going to say random.range, and then we want to go -45 to +45. So what this is saying here, now that you're facing the middle of the game area, I want you to do a little bit of rotation on the z-axis in a random range between -45 and 45. So if you didn't have this and you just say give me a random number between 0 and 360 degrees, a lot of your ships will end up pointing in the wrong direction and they'll be flying away, and it will just be a waste of time, a waste of instantiation. And this works out quite nicely because you know that by doing these values here, they'll always be pointing towards the game area, roughly, but with a bit of left and right movement. And even though that sounds a bit constraining, when you do click play and you see these ships moving around, you realize that it actually does look quite fluid and quite organic, so that works nicely. And then here, vector 3.forward, why are we using the z-axis? Well, in 2D games, when up is y and right is x, they're always going to be rotating on the z-axis. That's partly why I prefer to use the 3D view for 2D games, because you're still using the z-axis for rotations. Okay, so let's go ahead and save this and click play. Switch to scene view again. And there we have it. Now all the ships are looking in their own personal directions. Great. Just going to crank up this number here to 500. Ship mania. Okay, more ships, more ships. So what we have here is pretty nice. Again, I wouldn't worry too much about the extra ships here because they're coming into view, and if you want to have a nice selection of ships looking in all different directions, it's not that expensive to have a couple of ships here running up into the game. If we go to our game view, we have this nice like traffic, debris field, whatever you want to use this effect for. It's nice. It's really nice. Now for the most part, I'm just going to stop this here. Now for the most part, this is done, right? You click play, you got random ships, great. But it's kind of like a simulation because when you click play, you have maybe 5-10 seconds where you have to wait for all of these ships to enter the screen. You know, the screen hasn't quite filled up nicely yet with a nice mixture of slow and fast ships. You have to wait. But what if you just want to click play and then you want to see action straight away? Okay, so let's go ahead and do that. Let's jump back in the script. Here we go. So on update, we maintain our population, but on start, we want to create an initial population that's already in place, already on screen, so we don't have to wait for the simulation to build up. So we'll create a new function here called initial population. Initial. And then before this, we will make the function void initial Okay. Now the code is going to be pretty similar to this bit, although we're not going to be worrying about ships per frame, we're going to be worrying about the total amount of ships. But if we copy this, paste this in here, we're still going to want to get a position, create the ship, and then rotate it. But for the for loop, instead of saying if I is bigger than ships per frame, we're going to say if I is smaller than ship limit. So what this will do is it will say when the script starts up, I want you to quickly loop through the entire amount of ships available, 200, and make all of those game objects. So when I click play, all 200 of my ships are already on screen, they're already moving, and they've already got a random direction. So it's great, so you don't have to wait for the build up, and you don't have to wait for it building up off camera either, it can start straight away. Okay, so but there are a few changes we're going to have to make here. So when we get a random position, we are getting a random position outside the game area, along a circle. However, we want this to be in the game area, on play. So we're going to have to modify our getRandomPosition function here a little bit. So we need to add a bool to it, and we'll say within camera. So that's now saying get me a random position, whether it's going to be on the edge of the circle or within the circle, so within the camera view. And then if it is within the camera view, we are just going to want to get a position here inside the unit circle. We're not going to want to normalize it to push it to the edge. We're going to want it inside. So we'll get rid of that normalize there, and we'll push it into an if statement. So we'll say if it's not within the camera, if it's on the edge, then I want you to change the position that you've created inside the circle, and I want you to normalize it to push it to the edge. Okay, so if this is true, it will get me a random position inside a circle, and then offset it and scale it. If this is false, it'll get me a random position inside the circle, and then it will push it to the edge outside the game, and then it will offset and scale it. So now we have a bool here. We can add our argument here, so we can say true and false. So when we start up, we want the position to be on screen, and then when it's running, we want the position to be outside the screen. And then lastly, we have one final change to make. So when we're creating our ships outside the screen, we want to tweak their direction, but still face the game area. However, when we create our ships at the beginning, when they're randomly inside the circle, we can just say, get me a random rotation between 0 and 360 degrees. And that will say the ships that spawn on screen at the beginning will be pointing in a random direction, which is exactly what we need. So let's save this, go back to Unity. Got any errors? No, looks good. Click play. And then bam, it works straight away. It's all flowing nicely. You know, you got your fast ships coming along, you got your slow ships moving along. Wait, where's the slow one? There we go, one there, we've got them zooming along here. And if we go to our scene view, you can see they're all scattered around, moving nicely. And then if we go crazy, we go to our ship spawner and we change it to something like 2,000, 200, 2,000. You can see there we go, got the ships coming in. They're all at their +1 Z value here, and then +2 for the background. Nice. Nice and random. Now I think the cost benefit of having a couple of extra ships out here outweighs, you know, having to do loads of calculations to try and get everything to spawn perfectly in a square. I mean, this works perfectly for what we need. Go back to this view. Lovely. We have a nice random field of ships. You can replace the game object or the sprite with asteroids or traffic or dust or locusts, you know, insects, or maybe some kind of alien plasma field, you know, whatever you need. And you can really crank these numbers up as well to something crazy. If you want speeds of, I don't know, 110, and then you click play again. Pew, pew, pew. Now they've gone from looking like ships in traffic to actual flies dancing around something. But yeah, let's change that back to what it was before. Okay, so I hope that was helpful, and I hope that you can make use of that in some way. Now you can end here if you want. I'm just going to go and add the doc strings. But if it was helpful for you, please like and subscribe if you'd like to. And thanks for watching. So let us go back to our script. Pause this now. I thought I'd say goodbye before I do the doc strings, so that anyone wants to bail out can do so. Okay, initial population. Let's do some simple quick doc strings as usual. So let's do the maintain one first, actually. Just deleting everything, sabotage my own script. Okay, so in maintain population, you are to create more ships as old ones are destroyed, while respecting the object limit. Okay, but then I'll leave that open for now. And then in the initial population function, we'll say, to avoid having to wait for the ships to enter the screen at startup, create an initial, hello Heisman, set of ships for instant action. Okay, next we have get random position. So this one is get a random spawn position using a 2D circle around the game area. And then finally add ship. We will say add a new ship to the game and set the basic attributes. Cool, so that one's done there. Now my values here are actually quite bad for the defaults for me personally, so I'm going to change that to 80, 90 and 12, 0.75 and 150. These, if you follow along this tutorial like word for word, then these should give you some nice values. And then we just have two more, which is inside the ship script. So remove ship is update the total ship count and then destroy this individual ship. I thought I'd keep doc strings in the video just because it's nice to kind of, for anyone that wants just that little bit extra, I could just run through it again and explain what each function is doing. I find it helpful for me. If you find it helpful, you know, even better. Okay, and last but not least, the move function will move this ship forward per frame. If it gets too far from the game area, destroy it. And there we go. So I'm just going to go back to Unity and click play, just because this is where things break. And then you publish the code and then someone's like, it's broken. It's like, okay. So let's click play, make sure it's all good. Yes, got our initial population. Looks great. Crank up the limit a little bit to 500. Beautiful. Crank up the speed so the new ships coming in are faster. Perfect. I think that's everything. And my background texture here was actually 720p. So it was this resolution, 1280 by 720. So when I set the background values here, the scale values, I've kind of done the same as the resolution, just divide by 100. Kind of keep them up. And click play. Okay, anyway, I'll stop rambling now and I'll say goodbye. I'm making a list of really cool ideas which I wanted to share with you and slowly trotting through it, so awesome. Okay, take care and thank you for watching.